The concept being explored is both fascinating and unsettling, revealing profound mysteries of the universe. Scientists have discovered massive, luminous deserts in space where, instead of the glow of countless galaxies and stars, there exists an eerie void of darkness and emptiness. These peculiar anomalies in spacetime not only stand out from the otherwise dense and dynamic cosmic landscape, but also challenge the fundamental laws of physics. They hint at phenomena we are far from fully understanding. Known as cosmic voids, these immense regions lack significant matter, defying the expectations set by Einstein's equations of relativity and questioning the uniform structure of the universe. The sheer size of these voids is staggering, often stretching across thousands of light-years. To put this into perspective, a single beam of light traveling at nearly 300,000 kilometers per second would take millennia to traverse one of these vast regions. These voids rival some of the universe's largest known structures, such as the Virgo cluster or the Laniakea supercluster. They are not entirely empty, however, as isolated galaxies are occasionally found within them, lonely islands of light in an ocean of darkness. These sparse galaxies make the voids even more haunting, as their presence raises questions about the processes that formed such barren zones. What could cause these vast voids in the fabric of spacetime? Are they the result of normal cosmological processes, or do they point to phenomena beyond our current understanding? Scientists consider these voids to be among the most perplexing mysteries in the universe. Even black holes, which are notoriously enigmatic, are better understood than these cosmic empty spaces. One of the most notable examples is the Boötes void, a colossal expanse discovered in 1981 by astronomer Robert Kirshner and his team. Spanning approximately 330 million light-years, this void was initially dubbed the Great Nothing and was thought to be a rare anomaly. However, it was soon realized that it was not unique. Many other voids have since been identified, some even larger, such as the Eridanus void and the Northern Local void, which extend over 500 million light-years. Together, these voids constitute a significant portion of the cosmos. The study of these voids often intersects with concepts like dark matter and dark energy, which are central to modern cosmology. Some theories suggest that the size and distribution of voids could offer valuable insights into the nature of dark energy, believed to drive the accelerating expansion of the universe. Additionally, the apparent emptiness of these regions may conceal unseen forms of matter that do not emit light but exert gravitational influence, such as dark matter. To visualize the universe, imagine it as a soccer field. Galaxies and galaxy clusters would be small patches scattered across the field, while voids would dominate most of the area. Matter within the universe is distributed unevenly, with about 10 to 20% concentrated in galaxies and clusters, while the remaining 80 to 90% is found in voids and the spaces between them. This imbalance underscores the significance of voids in shaping our understanding of the cosmos. Voids also serve as natural laboratories for studying the effects of gravity and dark energy in environments with minimal visible matter. Observing the faint galaxies within these voids and the gravitational effects on light passing through them can provide valuable data on how matter interacts across vast distances. Additionally, by analyzing the shapes and growth rates of these voids, scientists can gain insights into the properties of dark energy, furthering our understanding of the universe's expansion. Consider, for instance, if our galaxy, the Milky Way, were located within such a void. This thought experiment harkens back to Edwin Hubble's groundbreaking realization in the 1920s that the Milky Way is just one of countless galaxies in an expanding universe. Similarly, the study of voids challenges us to rethink fundamental concepts and explore uncharted territories in cosmology. In summary, these immense cosmic voids, with their haunting emptiness and scattered patches of light, represent one of the universe's most profound mysteries. They challenge our understanding of spacetime, gravity, and matter, compelling us to explore the unknown and expand the boundaries of human knowledge. The presence of cosmic voids makes the universe feel even more mysterious. These vast, empty regions in space represent a cosmological phenomenon that could fundamentally alter our understanding of the universe. What causes these immense voids in the cosmic structure? Are they simply the result of natural cosmological processes, or do they point to phenomena we have yet to comprehend? These voids, puzzling researchers for decades, are enormous, so large that their existence cannot be attributed to mere chance. They must serve a unique purpose or be the result of extraordinary cosmic events. Voids are immense, empty regions surrounded by galaxies and galaxy clusters, yet they remain among the most enigmatic features of the universe. Even black holes are better understood than these cosmic voids. One of the most famous examples is the Boötes void, described by NASA as a vast region spanning hundreds of millions of light-years, nearly devoid of detectable matter. Discovered in 1981 by astronomer Robert Kirshner and his team, this void was initially thought to be a rare anomaly. However, it was later revealed that many such voids exist. Some, like the Eridanus void, over 500 million light-years across, and the Northern Local void, are even larger. Collectively, thousands of these voids account for a significant portion of the universe. When discussing emptiness in the cosmos, terms like dark matter and dark energy often arise. It's intriguing to consider how these phenomena may be connected. Some theories suggest the size and distribution of voids could provide critical insights into the nature of dark energy, which is believed to drive the accelerated expansion of the universe. Additionally, where visible matter is absent, invisible structures like dark matter may dominate these regions. This makes voids a prime focus for studying the distribution and behavior of dark matter. To grasp the significance of voids, imagine the universe as a soccer field. Galaxies and galaxy clusters would occupy tiny patches of this field, while voids would take up most of the area. Galaxy clusters and superclusters constitute only 10 to 20% of the universe's mass, while the rest is the in-between voids. With 85% of the universe composed of dark matter, these voids may reflect its distribution on a cosmic scale. Voids are also valuable for studying the effects of gravity and dark energy in regions with minimal visible matter. Gravitational interactions in these areas are revealed through the motions of sparse galaxies and the light passing through voids. For example, the light from objects behind a void bends and shifts as it traverses the void, providing data on how gravity behaves across vast, nearly empty distances. This allows researchers to draw conclusions about the properties and distribution of dark matter within the voids. Furthermore, the shapes and dynamics of voids can offer clues about the universe's expansion and dark energy's influence. Researchers meticulously study these vast empty regions to better understand their structure and growth, which in turn sheds light on the universe's evolution. Imagine if our galaxy resided in one of these voids. If astronomers of the past had been within a void, they might never have observed other galaxies. For instance, in the 1920s, Edwin Hubble discovered that Andromeda and similar objects were separate galaxies outside the Milky Way, revolutionizing our cosmological understanding. However, if Hubble had lived in a void, he might have seen only darkness and assumed the universe beyond his vantage point was a vast emptiness. This perspective highlights how limited our understanding can be. It wasn't until the 1960s that technological advancements allowed astronomers to see far enough to detect galaxies beyond their own, revealing a far richer and more complex universe. By the 1980s, the discovery of galaxy clusters would have seemed baffling to those in a void, given their perspective. Our view of the universe has expanded over time, from focusing on the Milky Way as the center of the cosmos to understanding that it's just one of trillions of galaxies. Voids remind us that our understanding of the universe remains incomplete. What we consider normal may be the exception elsewhere, and the mysteries of these vast empty regions continue to challenge our perception of the cosmos. In 1923, Edwin Hubble observed the Andromeda Nebula and other celestial objects, marking the first time these were identified as independent galaxies outside the Milky Way. This groundbreaking discovery reshaped humanity's understanding of the cosmos, expanding our view of the universe significantly. Today, we estimate the existence of roughly 2 trillion galaxies and can observe over 45 billion light-years in every direction using advanced telescopes. Had Hubble resided in a galaxy within a cosmic void, he might never have identified another galaxy in his lifetime. From such a vantage point, the universe would appear sparsely populated, leading to the false assumption that beyond the local collection of stars, there was only an immense emptiness. It wasn't until the 1960s that technological advancements enabled astronomers to detect galaxies even in these remote and sparsely populated regions. By the 1980s, astronomers began identifying the first clusters of galaxies. The discovery of these mysterious structures would have been astonishing to a hypothetical scientist in a void, as their isolated perspective might suggest a universe far less populated than it truly is. This stands in stark contrast to the path of human scientific understanding. Our journey began with the study of the Milky Way, which was once considered the center of the universe. Observations then expanded to include the Sun, other stars, and eventually planets, revealing that all stars are suns with potential planetary systems. This linear progression of discovery has continually reshaped our understanding of the universe. Each surprising revelation offers fresh insights into the cosmos, revealing that what we perceive as normal might be the exception elsewhere. The discovery of cosmic voids exemplifies how limited and uneven our view of the universe still is. Cosmic voids are vast regions in space with an unsettling lack of matter, where instead of countless galaxies and stars, there is only darkness and emptiness. These anomalies starkly contrast with the more densely populated regions of the universe. Even more intriguing, they challenge established scientific models, including Einstein's equations of relativity, and raise questions about the uniform structure of the cosmos. The immense scale of these voids defies conventional cosmological theories. They span millions of light-years, distances so vast that even light, traveling at 300,000 kilometers per second, would take millennia to traverse them. These regions rival the size of the largest known cosmic structures, such as the Virgo galaxy cluster or the Laniakea supercluster. Despite their name, these voids are not entirely empty. Within their vast expanses, astronomers have discovered isolated galaxies, like lonely beacons of light in an otherwise desolate landscape. These findings hint at the profound complexity and mystery of the universe, reminding us that even in the most seemingly barren stretches of space, there is still more to uncover and understand.